All right, here is one of the problems that my students are going to have to be working on today. And I'm going to kind of work through this one with them so that they're better prepared mentally to do the rest of the problems. Let's look at the situation that we have, and then we'll work it out step by step. Number one says, Ella is designing a poster and is placing a border around the perimeter. Her poster has to be 60 inches wide, and she is thinking of cutting it to the following lengths. Before she cuts it though, she wants to know how much border she will need. Now A says write an equation to describe the situation. B says complete the chart, and that chart's going to be our model. That's going to go along with thinking like a mathematician, number 4. And C says name the independent and dependent variables. Now I'm going to do something that I do not have to do. I've got students, they see me do this stuff and they think that they have to do it. You do not have to do this, children, but I am going to do this. I'm going to do this myself, okay? I'm going to make an example of what her poster might look like. Let's say that this is her poster, and I don't know if you can see it or not, but there is a red border around that poster. Do you see it? Mm-hmm. Now, it tells us that we have to write an equation to describe the situation. Well, I know that the formula for finding perimeter of a rectangle, and these are going to be rectangles. I had a student in my first period class. They asked, was this supposed to be a rectangle or a square? Well, when it tells us that her poster has to be 60 inches wide, and I'm going to put a W up there for wide, and here her lengths are going to be 50 inches long, 45 inches long, 42 inches long. That tells me it's going to be a rectangle. For it to be a square, I'm looking around my room to make sure I've got all my students actively listening. If I have the same length all the way around, it'd be a square. But if it's not the same length all the way around, it's going to be a rectangle. Okay. So, let's see. The formula for finding perimeter of a rectangle is going to be perimeter equals, I could say side plus side plus side plus side. I could say length plus width. Or I could just go ahead and say 2 times the length plus 2 times the width. I could do it that way. And that's the formula that I'm going to use because it makes it pretty quick. Now, let's look at, this is our equation to describe the situation. So this is our equation here. And it says complete the chart. So let's say that the length is 50. Okay, so I'm going to change the color of my ink, and I'm going to come over here, where I have a little more room, and I'm going to say P equals, now, 2L plus 2W. 2L is 2 times length, 2W is 2 times the width. Now, if our length is 50, well 2 times 50 is 100 inches, and 2W, and the width is 60, that's 2 times 60 is going to give us 120 inches. Then it's going to be perimeter equals 220. Is that right, boys and girls? You agree with that?
Yes.
Okay, then I'm going to go ahead and put 220. Now this is perimeter. Am I going to say inches, inches square, inches cubed? What am I going to say? Just inches. Just inches. It's a linear measurement. It's not a square measurement. It's not a cubic measurement. It just wants to know how long it is all the way around my shape here. Now, I think I'm going to change my equation. I'm going to change it, boys and girls, because while the 2L is going to change every time, because we have 2 times 50, 2 times 45, 2 times 42, is the 2W going to change? It's going to stay 60, isn't it? 2 times 60? And isn't 2 times 60 120, we said? So I'm going to say for my formula, I'm going to change it to P equals 2L, and that's a 2, it looks almost 2L plus 120. So I'm going to change my equation to this one. You see it? And I'm going to draw a line through this one because I'm going to let this be my equation. Now here it says 45 inches for the length. Okay, boys and girls, what's 2 times 45?
245 is
90. So perimeter is going to equal 90 inches plus 120 inches, and that's going to be what, children?
210.
210. So here it's going to be 210, and my unit to measure is inches. And then I'm going to do one more. My next one, here I have 42 inches. Now, boys and girls, what's 2 times 42 inches?
84.
84. So perimeter equals 84 plus 120. And 84 plus 120 is what, children?
244.
I'm sorry, say it again. 204, and our unit measure is inches. Now, I have to identify my independent and my dependent variables. Now, I know that my add-ins, like here's 100 and there's 120, those add-ins are independent variables. They're going to determine the parameter. The parameter is completely dependent on what the length and width are for its value. So, my independent variable is going to be, the length. Here, I'll put independent variable here. And the width is also independent. The width is also independent. So I think I'm going to go ahead and say length and width are independent because they determine the parameter. And P for parameter is dependent. It's going to be dependent because it depends completely on the value of the length and width for its value. And I'm going to say my math practice that I use for this one is I made a model, which is number 4. I could also say number 6, precision. I was very precise with the definitions of what independent or dependent variables are. And that's how I would do this one. Boys and girls, if I were a 6th grade student and I were the SFA PTM random reporter for my group, what grade would I deserve?
100.
Yes, I went through that and I told you my math practice. I showed you my process. I showed you correct answers, so I would get 100. How many of you feel very confident that you can do this type of problem yourself? Okay, I'm looking around the room. I see a lot of hands. I think that's wonderful. Very good.